So I guess like I currently I am in Kiev, and Nikita as well as no.
No, I'm in Odessa right now.
Okay. So Svitlana is in Bulgaria. It's also near the sea, right?
Yes, Black Sea.
So Kyryl, what about you? I saw like you had Canadian affiliations recently.
Yeah, I'm currently right now in Montreal.
Okay, sounds good. Well, and I know Maria currently is in Florence. Okay, so we all are in different cities. Well, so I think we can start somehow. Well, so hi to everyone. My name is Artem Chernodub. I work as applied research scientist at Grammarly. And happy to open the natural language processing panel to discuss current things. So let me please introduce our honorable experts. So first here is Kyryl Truskovskyi, who currently works in BorealisAI. It's a company, or is it research institution? I'm not sure.
Part of RBC.
Yeah. So like he's a machine learning software engineer, and his main interest currently is how to move models to production. So previously he worked in like famous companies like Ring, which was acquired by Amazon, and in Neuromorphic. So also we have here Svitlana Galeshchuk, who combines two areas, industry and education and academia. She is a data scientist, researcher in NLP in company Starclay in France, and also she works in Université Paris Dauphine. Yeah, so also we have Nikita Lukianets, like he's also a famous person internationally. So currently he is founder and CTO at PocketConfidant and AI, a startup company which combines natural language processing and psychology, like to do right advices. He previously worked in Microsoft, and he has rich experience in academia as well. And last but not least, here is Maria Nadezhde, my ex-colleague at Grammarly. I was really happy to work with she previously, and currently I'm happy to announce her. She currently works as a research applied scientist at Amazon Web Services. She got PhD from University in Edinburgh, and she's interested in like a lot of topics. The main one is neural machine translation. So am I correct? Is everything correct about experts?
Yes, thank you for introducing us.
Okay, good. Well, so I'm really happy like to collect all of you here, because I have a couple of questions from my person. And also, so we will divide all panel to two big sections. On the first section, I will ask you some questions, and after that we will get questions from the auditory. Well, so as for start, to discuss the current things in natural language processing, I have a general question to all of you. So recently, like recent 2 years, there was a popular phrase that NLP Imagenet moment has arrived. In NLP, like there's a famous article by Sebastian Ruder, who like speak a lot about it, about transfer learning. So I remember actually this moment in Imagenet in 2014, like when just Alex Krzyzewski trained his AlexNet, and like the VGG was highly used in a lot of domains. Well, so do you agree with that? So like for me, it's not obvious, because from one hand, currently we have rather like universal models, which are huge, which are heavy, which are universal, which have boost in a lot of domains. I mean, transformers, BERT, BART, like and so on. But at the same time, Alex Krzyzewski trained his model on having only 2 graphic cards, and it was enough. What first thing, and the second thing is that I'm not sure whether current heavy models are widely used in production. So, because actually they're heavy. So, what do you think about that? So, who wants to start? Okay, Kyryl, what about you? I think you work a lot with prod.
Yeah, sure. So I kind of agree with this statement. I definitely see a lot of progress in NLP, especially with transformers libraries and transformers like family of models. So it's kind of arrived. I think like the main reason that like the NLP task itself a little bit harder than computer vision. So you like cannot say like you solve the NLP with transformers and it's done. You just need to fine-tune. A lot of people like do currently this. They just grab some pre-trained model, fine-tune it in little samples, and put it in production or somewhere, right? So definitely things become much easier, and like you have like right now much lower bar to go into NLP and to do something useful. But in terms of computational resources, it's still bottleneck. It's still not solved problem, and you definitely cannot reproduce it. So I think like even right now you can train like state-of-the-art computer vision model at home from scratch, but you definitely cannot do this with NLP. You need to rely on some work from OpenAI or Google. So I'm not 100% agree with this statement, but I'm agree with like 19%. So it's huge progress. It's really like rapidly growing development, but not like a Imagenet moment.
The one more thing about leveraging big pre-trained models in computer vision was that they produced hierarchical-like representations. So I need to take a look on convolutional filters for other layers and ensure that like on first layers we extract like edges and some combination of edges primitives on middle layers and like hard complex patterns on highest layers. So for me it seems that AlexNet also explains this, means this. As for initial language processing, it's not obvious. So we started using word vectors, like word-to-vec embeddings 7 years ago, right? And it can be explained like or converted like just treated like leveraging edges by computer vision networks. But as for hardware levels, it is hard as for me to explain them, to treat them, to debug them. So, well, I want to ask Svitlana. So I know that he's interested in explainability of models. Can you please comment on that? Currently, how is it possible to debug big models, to explain their behavior? Yeah.
It's difficult to debug. Let me know if you can't hear well because connection is choppy, okay? Then I will switch off the video. So I tell you, I agree with you that understand the behavior of neural network and so speaking about the interpretability of the model itself, for example, BERT, as I told you, for example, the researchers from Facebook, they found out that by observing the attention heads, they found out that actually BERT puts a lot of attention, so focalizes on the limiters like commas and semicolons. Out that it exists syntax-aware attention in BERT, which may be one of the reasons of its success. And that's just observing the attention heads. Then, for example, the research from Germany, I believe. So they use the probing task, so-called probing task, the auxiliary, the additional classification task, to understand the representation after each layer of BERT. and they found for question answering tasks. And for example, they found out that the early layers of BERT, they try to cluster words. So they cluster Ukraine, Germany, and the word country into one cluster. The middle layers try to make them the entity linking, let's say, try to make the link between the names and the mentions and attributes that I actually do the facts for each question, and only the last layer actually extracts the answer. So you can see that the reasoning behind BERT is very close to human reasoning, because more or less what we are doing, the difference between us and BERT, let's say, is what Nikita actually mentioned a little bit. Then we, for example, read the text, we read it sequentially. And BERT, when he sees the text, he sees it together. So I know that I can speak about this more, but I also know that, for example, there are evidences that fine-tuning actually doesn't help much, especially for the classification task. The let's say contribution of fine-tuning is negligible. Maybe pre-training is sorry, but fine-tuning for classification tests, there are evidences that it updates weights in a very, let's say, negligible way. So there are a lot of, let's say, research doing in these directions to understand better the behavior. So it's one aspect. You can, I think that this year at ACE conference, there was even the tutorial about the interpretability and the behavior of the models, NLP models, so you can check on it. And there is another aspect, is interpretability of the output. So it's for us to understand, and especially for the end users to understand where actually this output comes from. So how is it possible for this sentiment? So we have the sentiment for positive 0.7, for example, something like this. And for that, there are already some tried and tested methods like LIME, so it's local interpretability model agnostic explainer. I think it's like this. It's based on perturbation of the text samples and then using the linear models, but then the linear models around them predictions. There is SHAP, which is based on the Shapley values. There is Captain, which is good for PyTorch models. So Captain is actually the framework of different approaches that help to, let's say, explain the output. So what I say that it's actually important to understand how it works. It works differently for different classification, answering, but it's far away from the human reasoning. And it's important to go far and to understand better in order to, let's say, transform this idea that BERT is the black box model to maybe gray box model. That's my overall comment.
Okay. So, but what is the feeling like? So, for me, currently, it seems that all these interpretability methods are more like demonstrations that it's possible at all, but not like is a tool for everyday use. So, do you feel that? Yeah.
It depends. You are meaning the interpretability of the model or interpretability of the output?
Mm-hmm. Okay.
Because interpretability of the output, you can actually, as I said, they're already, of course, you don't just apply it easily, but they are already tried and tested methods and already developed Python libraries that are not even that difficult to use, and I use it quite frequently. But interpretability of the model, so to understand how BERT reason for your task, yeah, it may be more difficult. It is more difficult.
Mm-hmm. Well,
I have a little comment on that. So if we're looking at interpretability solutions, for example, WT5, that's looking at every inference as a text-to-text problem in general. And what they're suggesting is that they basically a code that allows us to append, prepend the explain word to every text input and receive the output that will factor or point to the factor that that potentially made the machine give a certain answer. So what this allows us to at least have some understanding. And why this is important? This is important very much in financial domain and domain that has legal effect. So today, one of the regulators' requirement is to actually give the ability for the person to object the result of when the result is delivered by the autonomous system. So we need to provide a person an explanation and the way to loop back a human when we need to understand what went wrong or why the result is the way it is.
Okay.
The regulation very soon in a couple of years.
Well, as for me, as for interpretability, like in general, I really like approach, like alternative approach by a professor from MIT, Chernodub. So he works on like to make computers be able to write a software which is readable. So his like approach is like the ideal case if we can present artificial intelligence not as big trained models, but as actually software programs. But unfortunately, current programs are really tiny, so it's like his approach works for toy problems only. Well, okay, so as an example, I know that one of the hardest, the most challenging translation. So it's hard because first, like it contains a lot of hidden but important issues like meaning preservation. And also it is a generative task. So the model generates text instead of like making some discriminative decisions. So yeah, it's hard one. Well, Maria, I wanted to ask you what's going on with neural machine translation in like 2020 and what is current state and what do you think will be the next steps in this area?
So I'll agree with you that it's a very difficult task because you don't have to just learn representations of one language, but two or more, and then learn mappings between them. So I think it brings a lot of challenges, interesting challenges. And as you mentioned that earlier about whether the pre-trained model are the solution for everything, I think there's been some interesting results in using pre-trained cross-lingual models to initialize the layers of the neural machine translation systems for low resource languages. So I think that's a very active area of research because traditionally machine translation has had to work with a lot of data, so it doesn't suffer from that problem as much. So there's been a lot of work for European language pairs where the training data has millions and millions of parallel sentences. So for those high resource scenarios, neural machine translation, has proven for like a few years now that it's really great. But there's a lot of interesting work happening on low resource languages. And one aspect that I'm excited about is training multilingual models. So you don't just translate from one language to another, but from one to many, or from many to one, or many to many. So that's one way to leverage high resource languages with high resources and transfer some of the information. For example, I do believe that higher layers of the transformer start learning syntax and more like interlingua kind of representations that then can help in the zero shot or low resource scenarios. I would they'll make a pause here and say that what is low resource in academia is not necessarily low resource for industry. So while in academia, research, I think, is mostly focused on English, let's say, or maybe European languages. And therefore, there's just less resources to invest in data crawling and so on. In industry is less of a problem, but still there are so many languages, so you can always find a low resource language. So other aspects that I find interesting are also the problem of robustness. Also thinking about industry, there's been actually a best paper award at ACL about implementing an NLP checklist for your models before deploying them. So robustness is one issue that we need to worry about, especially for neural models, where you have less control over what the model does. And then you can have surprises like hallucinated words and so on. So it's an active area of research as well, understanding how your model fails. Some other direction I like is control generation. So for big language pairs, neural machine translation outputs fluent translation, but there's interest in trying to control it. For example, changing the style to make sure, for example, the translation matches the formality of the input sentence or input document. So I find that very interesting. And there was actually a funny paper, or a paper that had a funny title at ACL. The title was "You Sound Just Like Your Father. Commercial machine translation systems include stylistic biases." And an example was that our machine translation systems might output something like, "Would you be inclined to participate in a game of soccer?" when somebody else in an informal situation would say, "Wanna play ball?" So this is one challenge, I think, that we have now, and it has to do with how we just crawl data from all the sources and then try to feed it into the system. And I think now we are at a stage where we can think more about how do we control the output of the neural machine translation system to control for formality, for readability level. And another recent line I heard was combining machine translation and paraphrasing. There was one of these other large pre-trained model called Marge that changed the objective to paraphrasing, and the model learns to do all sorts of tasks, including machine translation and paraphrasing. So I think that that's a good example of demonstrating that your model really learns to represent multiple languages if you're able to do both translation and paraphrasing. And I could go on, but I guess maybe one thing other things that I would mention is that there have been some work showing that even with large pre-trained models, it's good to still focus on domain adaptation. That's really a big challenge. Domain adaptation and adaptation to the task. So I think that's there's more to explore there in terms of addressing catastrophic forgetting. So there's been different papers that and work that addresses that, on trying to make a schedule for training your models when you're multi-domain. If more resources doesn't drown out the one with the domain with less resources, or the language pair that has a lot of resources doesn't drown out the low resource language pair. So stuff like finding curricula for training, and something was elastic weights, I forget what was it called, was very interesting.
Okay, so but what if we take a look under the hood of these models? So are they all transformer based?
So mostly. Yeah, definitely transformer based are very successful. But again, it also depends on how you want to apply it, because there is a need for more low latency models where you, like I think there was the team at Microsoft that changed the architectures for a more lightweight decoder. And just to address the fact that, for example, they use it in Skype translator where you need to do live translation and so on. So I think it also depends on how you want to apply these models. And there's also a lot of optimizations that have happened lately. There's this workshop on natural language generation and translation. It was at ACL as well, where they presented a lot of improvements in terms of training, distilling the models, and making inference fast, making it deployable on CPU. I think a lot of those improvements are implemented in the Marian Neural Machine Translation Toolkit. So I think that's a really good resource to look into.
Okay, well, good, thanks. Well, but I'm like, despite of like trying to optimize at least inference for such models and like try to make weights pruning and so on, I heard that from Nikita that there exist really neuromorphic architectures. Am I right? Which can help to solve this problem. Nikita, can you comment on that?
Yeah, well, I think I have to make a disclaimer first that I'm not working on neuromorphic architectures for, I think, for 3 years already since I left my academia path. But I think it's worth looking at. So first of all,
okay. We simply changed our like main topic is neural language processing in 2017, and everything is fine, right?
No. So when we talk about neuromorphic architecture, what do we need to understand? Why we even raise the subject? We raise the subject because of the energy efficiency of the model and time it takes to compute. For example, and what the idea of neuromorphic architectures is to create systems based on either networks or in silico, in hardware, that will be able to do inference for us in the brain. 80 to 85% of that is used for training. So it means that we have to almost multiply this by 10, and this would be the comparison of energy efficiency of such models. And what the approaches that are used today there are two lines of approaches. The one line of approach is to use the architectures that are very, very much brain similar and trying to implement it on the classical hardware or even on Google's TPU, Tensor Processing Unit. Or another line of approach is to create such a hardware that will be very energy efficient on inference, meaning that we would be able to have our model trained probably on the classical architectures, the way we used to train it. And then we will have a process that will transfer this learning from our software model to a hardware model to a chip that we will use and retrain if we will need to retrain it. So we will have a hybrid architectures that will constitute of something that uses very small amount of energy, plus in addition to it a software block that will reuse the inference from this hardware to make the processing more energy efficient. But to my knowledge, there is no ready-to-use solution for natural language processing and computer vision. There are just several approaches that has been tested for recurrent neural networks in the, let's say, in the lab condition. So it's not used in production, to my knowledge.
Okay, wow. So for me, like there are at least two surprising things. First is that like now I know why do I need chocolate and coffee to start work, and at least I can explain it to my wife. Yeah, and second thing is, well, for me it seems that such a neuromorphic models require more energy. Because like you need to simulate all such things, like all behavior, logical behavior, and so on. But Yeah. So, but the question is it will be possible to simulate on current hardware, or do we need like to create a special hardware for such neuromorphic algorithms?
So there is a company that I suggest to look at. The work that they're doing is they're working on sparse computing, or so-called cortical networks. So in the human brain heavily uses our cortex, that is a layered network by the way it's organized, to do the computation and reasoning. So we do believe that this is what very much differentiates us from other animals.
Mm-hmm.
What is interesting is that Numenta is focusing on the software part of it. There is also a work of so-called Human Brain Project. So Human Brain Project is a pan-European research project with a funding of €1 billion to work on neuromorphic architectures and to work on brain-inspired computing on different sides. There is an IBM work that is called True North, if I remember it correctly. So it's a chip that does the computing. But to make a comparison, if I'm not mistaken, this chip uses 1 million of artificial neurons for the computation, while human brain has.
Okay. Well, just before the next question, I have a message auditory, so please feel free to type your questions in YouTube channel, in Telegram channel. So we'll try to answer. Oh no, experts will try to answer it. Well, and so okay, well, sounds good. But currently, like this new hardware is not available to buy in Rosetka, in like on Prod or such instances in Amazon Web Services. Well, and running big models in production. So challenges currently are, so at least currently I have a question about GPT-3 model. Do you think it's like possible to run such powerful models in prod in real world situations? So for me, this looks like they are record holders. So they show like great examples of behavior, but it will not work for business.
Yeah, that's
well. And what currently issues are, and what do you think will be like next steps before neuromorphic processors and models will appear?
Yeah, thanks for the question. So it's true, most inference right now happens. It's extremely hard to run big transformers model into production. But it's also good to understand that parallel to research track, there exists like a productionizing track, which involves really great in the latest time. And so, for example, most mainstreams machine learning model server solutions, for example, like Triton inference server from NVIDIA or a PyTorch server from Facebook and AWS, they support transformers just out of the box, and you can easily serve it. And there's a huge development in optimization technique. So, for example, like turbo transformers from TenseNet and ONNX runtime from Microsoft. So you can easily reduce the computational cost of your transformers library. So I believe for mid-sized transformers or for small-sized transformers, like the tooling is here. And if you have use case when your transformers model performs significantly better than, for example, logistic regression on top of words embedding, you definitely can put into production and be successful. But with the small nodes, like 99% of cases, you're talking about small bird models, like these still birds or tiny birds, when you just basically just reduce size of the model and perform a lot of hacks. So, for example, there's a huge, like really cool work how to serve your transformers and handle 1 billion requests per day on a CPU only. And they also like show really great progress, how they start from a single bird, then they move to the still birds, then they move to quantization, and they try and reduce computational costs. In terms of if you would like to serve like a big transformer models, like even bird large, I believe if you have more than 100 million parameters it's very unlikely that you're going to production because the computational cost will be extremely high and it wouldn't be economical feasible to serve this model. I think the main issues with serving BERT and serving transformers is computational cost, robustness, fairness, and stability. So the main issues with serving machine learning models are still the same, but the computational cost much higher. About GPT-3, yeah, I believe it's really impressive what it can do, but I don't think that will be there will be quick production adoption for it, even if it's going to be published in open source. Because even serve this model, which the size of the model itself, from 300 to 700 gigabytes, most companies even don't have data sets like this, and we're talking about just serving this model. So yeah, what you can do, the best of my knowledge right now, is just to serve some reduced size BERT into production, and it's extremely hard, it's extremely expensive to serve big BERT models. Not talking about GPT-3, it's completely unfeasible right now, I believe.
Okay, so and do you believe that situation remains the same for the nearest future, for a couple of years?
Couple of years for sure. Yeah, and especially in a maybe not in research area, but in production area. Yeah, it will be the same for a couple of years, I believe. Of course, it will incrementally improves. Your compute become much faster, and the model become much accurate and tiny. But if there's not a huge progress, someone create some chip which will be ready to manufacture in production scale, situation will be pretty the same. You basically will need a supercomputer like OpenAI has to solve this kind of model, and which will be extremely expensive. And majority of companies who trying to run NLP based product will use much smaller models.
Okay, so well, for now it seems that for ongoing years the only recipe is how to use big transformers, is techniques
to reduce size.
Yeah, it's or to reduce size, or to use model distillation, and or what else? Build smarter models with smaller decoders.
Yeah. One of the ways, just play with architecture. Maybe for your problem, the classical NLP models works as well. It's not always the case that you need the transformers for some simple classification, and yeah.
Okay, all right. So, well, we are open to questions, but to the moment we don't have questions from auditory as far as I see. So fortunately for me, we continue with my questions. But yeah, again, so if you want to ask to our experts something, this is the great chance to do it.
Actually, I have one question for Svitlana. If you.
Oh yeah, you are welcome for sure.
Yeah, thanks. So, so my question, my understanding, I'm really interested in the explanation area, and my question is the next. So I know that the primary usage of explain output is to better understand and debug your model and improve it. But is there any production application when you try to expose the output explanation to an end user?
Sure.
When you're basically trying to improve user experience or your product.
Yeah, so that the user can validate the results.
Yeah,
yes.
or understand something and learn.
Or understand. Yeah, indeed. So when I mentioned, thank you for the question. So when I mentioned Lime and Sharp and so on, there is, for example, the Python library, LE5, or even Captum. So they have the output you can actually present as in the web, even in your web application, let's say, because you can, for example, highlight with the green color those words that contributed positively to the results, and in red that contributed, let's say, negatively to the final result. Also, the shades of green will be more intense when the word, for example, diabetes, when you try to prognose some kind of the disease. Yes, the word diabetes could be, for example, in very intense green. It means that this word contributed the most to the final prediction. So yes, you can actually do this. You can already develop methods by just coloring, let's say, words that contributed in the final prediction. And as I told you, check Captum AI, it's for the PyTorch models. Then check Lime. Lime is for whatever models, let's say, and SHAP, but because Lime is a model agnostic explanation. And SHAP is based on Shapley values. So in permutations, there is also the Python library, and it works kind of the same way. And actually, I had very good experience with this. So I worked with hospitals in Paris. Why I mentioned this diagnosis? Because I needed to, we needed to, let's say, predict the diagnosis. And you can imagine if you, for example, say to the doctor, okay, so here there is 0.7 probability that it should be, I don't know, heart disease, something like a heart insufficiency. I mean, the doctor will tell you, yeah, it's fine, but how can I believe it? So then it was very nice because from the text of the patients, so patients come to the urgent care and they, for example, explain what's happened to them and maybe their clinical history a little bit. So I took this text, and just from this text, I tried to make the prediction of the sickness, of the illness. And at the end, actually I used Lime and SHAP to make a comparison, and a bit Captum. I think it was very nice because we could find out the set of words that contributed, that were like symptoms and possible causes that contributed the most into the classification results. They were highlighted with green color. And also those words that actually had nothing to do, those symptoms that had nothing to do with the kind of the disease, highlighted with the red color. So yes, it's, and the doctors could understand, and actually we actually found out some nice results, yeah.
Yep, thanks, Max.
Okay, here's a couple of questions from auditory. I have a question from Mariana. What is the best way to eliminate social bias from the DL models nowadays? There have been a lot of criticism regarding existing methods in the papers lately. Is the bias in data is the only effective way? Well, so probably I can address this question to Maria.
Good question. I would think Svitlana maybe would know more since she works on interpretability. I think there's been a lot of discussion, all sorts of discussions. A lot of focus has been on what data you use. So that's, for example, in machine translation, one of the problems that people looked at a lot at was when you translate pronouns and you required context, and maybe that context is missing or is present, the gender of the pronoun that your translation model picks is important. And sometimes there is enough information in the context to disambiguate a pronoun, sometimes it's not. But a lot of research was looking into how by default the model will pick a masculine pronoun because that's the most frequent in the data, or model has some biases that are not handled. So I haven't worked so much myself on this topic. I know that, for example, there was a paper at ACL that was looking at balancing the training data and together with fine tuning and addressing the catastrophic forgetting with elastic weight constraints or something like that, in order to make the model handle this problem better. And I think there have been some invited talks at NeurIPS and iClear perhaps that have actually just framed the problem quite differently. Is first you need to understand what your users are, what your problem is. My opinion is that you should do some user experience testing or something to understand what are the exact problems and how your model is failing. And it's not just about the data, it's about how you design your algorithm, what is your application, and so on. But I don't have expertise in this area that I could share at this moment. So yeah, I don't have a better answer.
Okay, so I want to add that organizers of this panel really care about the biasing, and so like we have there is by gender. So we have 2 men and 2 women, and yeah, we all care about that. So yeah, so I have.
That's the only reason why you have 2 women and 2 men is because you hear about the bias.
Well, because of my experience, well, let's not touch this topic more.
No, I'm just joking. I'm just joking. Don't take it personally.
Yeah.
I wanna add to Maria's comment is that's true, but I'm gonna add with actually the comment of Lucan. You remember recently there was this a bit of a scandal about fake face, or I think it's called like this, when Obama became white actually. And then Lucan, I think, commented on this, saying that if you train your model on the biased data set, then you will get the biased model. So one of the most important actually issues about training the models and getting the unbiased model is to have the biased data, having as many Black people as white people, let's say, and so on.
Yeah. Nikita is raising hand.
I found some, I copied some resources I had noted, if anybody would be interested in looking them up. Should I read them now, Artem, or do you want to go to another question?
Well, actually, I think, yeah. Let's please send it to me, and we will share it
okay,
a bit later. Because our discussion is going to the end, so I have one more question to all of you, to each of you. Can you please tell about the most unpredictable result which you got in your experiments, like in your career? So.
Yeah, I can start. It's actually when I trained Roberta-based model on 300 samples for 10 classes, and it performs well in production. It was actually very surprising to me. Like, it's not such outstanding result, but it was very, very surprising. It's like you need so little amount of data to like perform classification 10 classes. Like, it didn't perform bad, but much higher than I expected.
Okay, great. Who else can share his experience?
We had a story when we were trying to assess how users react to smiles in the text. So I'm talking right now about the product that we're building called PocketConfidant, and this is basically a virtual coach, a tool that asks questions in return to the text that the user submits. And our previous product that we had was a chatbot. So we built this chatbot on our API, and what API was doing basically was taking the text as input, generating questions, and shooting it back to the user. And then the user was answering again and again and again. So initially, the idea was, can we do a style transfer? Can we understand the tonality of the language that the user is talking to us with and transform our output, and by preserving meaning and outputting the same tonality, or matching the tonality of the input. And we also saw that we have a big problem because some users were using a very standard text, but then adding smiles to this text. And we didn't know what to do. We were not able to match it in any way. So what we did, we tried to run experiments and try to encode this. It didn't work. And then we did just a simple regex when we extracted smiles, and we inserted smiles back at the questions, and we raised the engagement at 20%. It was fun. So there was no deep learning, no natural language processing involved. We just used smiles when people were using smiles.
Okay. Does someone wants to?
So
yeah.
I already, yeah, it's I will be short because I already spoke about one of the recent experience. Okay, actually, the best, the most unpredictable results you get when you make some mistakes and then you get 100% of accuracy or 10% of accuracy. But then, but otherwise, I already spoke about one of the recent experience I had with the hospitals. And as I told you, I got quite good results in terms of F2 score. Because recall is more important in medical research, and having not that much of data. And what was also interesting, that using the interpretability, we could detect some causes that were actually seen undervalued, underestimated. So I found out some medicines that could be potentially more harmful. And also I found that, for example, hysterectomy, which is the surgery that some women need to go through, actually may cause the stroke. And I saw that it's only since 2017 that actually it has been recognized as the cause for the stroke. But my classifier do this as well. So I think it was quite interesting and unexpected, and maybe also having some human input, let's say, that it may have some impact.
Okay, and Maria, what about you? Did you have some unpredictable things in your career? And
well,
effects, yeah.
Well, I should mention I did work with statistical machine translation at the beginning of my PhD. So once I switched to neural machine translation, I was obviously very surprised for how easy you can get such great results with much less complicated pipelines. But more on a high level, I think the most surprises you get is when you've not thought out the problem you're working on very well, when you have not invested enough time in finding good evaluation sets, and when you do not make sure to try to understand, if you're working in industry, what is your user data, how does your model perform once you've gone from initial research to actually trying to deploy the model, and try to understand what are the surprises. That's where the problem of robustness comes in, and where you can have a lot of fun by looking at how your model fails or how your model hallucinates. So I think even when you have access to pre-trained models and Hugging Face libraries and so on, there's a lot of time that people need to spend looking at the data, looking at evaluation sets, using the right metrics in order to understand if they're making progress or not. And in the end, you will always have a long tail of issues, like the issues with smiley faces or I don't know what, that you will have to find ways to fix. And there might not be just one, two, there might be several. So I guess just a higher level of, there's infinite sources of surprises that you will get in NLP.
Okay. So I will add my case, just to recall it. So it was not actually related to research, but it's like concerned related to bias and relationship with project manager. So actually I was a person who developed a cat face recognition algorithm in 2014. And at that time it was a like huge experiment. We were mentioned by famous website, as a startup of week and so on. And actually my project manager was really surprised that one of cats was associated with his son. He was very angry because of that. So, and you know, like for me, it's okay because it's an algorithm. It makes errors, sometimes makes tiny errors, but and he also understands that. But it was something, you know, dependent to the right side of brain. Well, and it's related to biasing, and we need to care about that. Yeah, so well, it seems that unfortunately the time is up. Well, I would like to say very much huge thanks to all experts who joined to us, to organizers of fwdays virtual conference. Well, and to all listeners who joined to us, who sent questions. Well, so thank you all, and hope to see you, each of you, and maybe together sometime later.
Thanks, Artem. It was great speaking with you again and meeting all the other NLP experts.
Yeah.
Thank you so much, Artem, and the rest of our group. I hope to see you soon, and surely at the ACL conferences and also in Kyiv.
Oh yeah. By the way, you know, like the next year's ACL conference will happen in Kyiv, thanks to Grammarly and Ukrainian Catholic University. So, well, if you all will meet me there, that would be great. Yeah.
That's great. Yeah.
Thanks a lot, everyone.
Yeah, thanks so much.
Thank you.
Okay.
Bye.
Okay, so yeah, bye.
Bye.